Thanks, everyone. So I'm here with my colleagues, Clay Howey and Kelly Carmichael, to talk about our latest project, Innovations in Electric Vehicle Charging. First of all, just to give a bit of background, because I'm sure there are people here who don't really know what we're about. The Smart Microgrid Applied Research Team has been around since about not necessarily with that name, but since about 2009, I guess, working on microgrid technology and concepts. So basically, advancing the state of practice for microgrids. That's a very big bucket. So I guess to drill down a little bit, the areas that we focus on are electric vehicle charging infrastructure, microgrids, and cybersecurity for critical infrastructure. We have a 10-person team who have been together for about 10 years. We've done a lot of cross-training amongst ourselves and through our partners. So we have people who are who have expertise in data communications and networking, computer science, electrical and power engineering, and we also have a lot of overlap with social science requirements, so obviously trying to work together with communities and people involved in taking the transitioning of green and sustainable energy forward from that perspective. Don't want to dwell on this too much, but just to give a background on some of the things that projects we've done around campus. Most of our projects are research, development, and demonstration projects. So we try and make our projects very relevant to research. They usually end up in some kind of a demonstration that will either de-risk or validate technologies that are maybe common technologies but are put together in different ways, or we use some of our infrastructure, like our Energy Oasis project on the main campus, which some of you may be familiar with in Lot 7. It is an actual functioning microgrid, so it's capable of working in conjunction with the BC Hydro grid and pumping some power back into the campus to help reduce campus electrical bills, as well as functioning completely separate. So if we had the microgrid hooked up this morning to this room, we would have been able to keep the power going. So it does that for the electric vehicle charging infrastructure that is in place. And I mention that because we have a number of things that we leverage that project for. So for example, there are 700 data points collected from that project right now. They're collected and stored and have been being collected since the beginning or the completion of the project. We've also leveraged it for the next project, the project that we've just completed, the one that we're going to talk about. So we're going to give you an overview of the project objectives, talk about the stakeholders, and then talk about some of the components of the project that we've just developed. And that includes streetlight and multi-unit residential building installations, looking at harmonics in multi-unit residential buildings, and what some of our next steps are. So the project objectives, the overarching project objective is to advance the adoption of EV charging in Canada, of the adoption of EVs in Canada. But we have to focus on a few areas that line up well with the granting program, as well as with our own areas of expertise and interest. So there are barriers caused, and we'll get into these each in more detail with the other speakers, but by the proprietary nature of communication protocols for the control of EV charging. So there are residential high density issues. A lot of people who would like to buy an EV, don't have the capability to do that because they have nowhere to charge it at home. And if you can't charge it at home, that's going to be one of your first concerns. So we were looking at ways to identify those garage orphans and to try and find a low-cost solution that would be maybe a curbside charging solution. We were also looking at that as a potential solution, should it be workable, for retrofitting in multiple EV charging units into multi-unit residential buildings. So the project demonstrates that we've developed an open charge point protocol, some low-cost curbside charging, and some ways to mitigate, if needed, things like harmonics that could cause damage to installations in multi-unit residential buildings. There were some very innovative ideas that were actually proven and de-risked during this project. The project has some field installations that these guys will talk about shortly, and the results were good because there are a number of municipalities now looking at adopting some of these procedures. We've actually been able to lower the cost for those by doing the non-recurring engineering costs as part of our project. We have had a workshop in February with a number of the municipalities in the Lower Mainland, and pretty much everyone agreed that the costs were significantly lower than a traditional installation. And you'll understand why by hearing about load management and load sharing with streetlight networks, which is something that we'll turn it over to Kelly now to have a go at this in a bit more detail. Oh, sorry, Kelly. One more. So just quickly, I'm just going to leave that up there for you guys to have a quick perusal of while Kelly's getting set up. But we had a number of stakeholders, and as I've mentioned, the municipalities are totally on board with this. Kelly can probably talk a little bit more about our work with CSA. So we're doing some work with Canadian Standards Association on electric vehicle charging specifically. And if I've missed anybody else, go for it. So do you want to use this guy?
Sure. Thanks. So I'm Kelly Carmichael. I've been part of the research team for 7 years now, just about 8 years. So for the last year, we've been working on an open charge point protocol. This isn't our development. We didn't come up with the protocol. We implemented the protocol that's available as an open standard. The existing standard that is widely deployed was version 1.5, and it had significant issues, and EV drivers are very well familiar with it, that there's problems with wide area networks, and they're using a cell-based network, which in North America gives dynamic IP addresses for IP communications. So communications back from the server to the charging stations were notoriously unreliable because they never knew where the charging station's IP was going to be from one day to the next. And there was a strategy to try to deal with that, but it never did work well. So there were definitely issues. They've moved up to a version 1.6J, which moved from a SOAP-based solution to JSON WebSockets, if anyone's familiar with that type of technology, which allows a bidirectional communication to be set up from the charging station, and then the server can talk to it anytime it wants without having to establish a new TCP connection out to the charging stations. So that works much better in a wide area network deployment like charging stations over a cellular connection. So what we did was make a user portal, administration panel for people to add and modify charging stations on their network. BCIT is actually our first deployment of this stuff, so the Oasis charging stations do have all these protocols implemented. We've written the client code that runs on the charging stations and the back-end server. It also integrates into a PCI compliant payment system. A lot of issues were initial in deployment for people would store credit cards on their own server, and of course that's not really kosher in this day and age. Everyone's heard of all the different break-ins of like Home Depot and people's credit cards being stolen en masse. So that can't be done anymore. So we've had to move to a PCI compliant solution. So when you interact with a PCI compliant system, normally you submit your credit card information directly from your computer to the bank information, and it never touches our servers or the vendor that you're actually paying with or paying to. And so that was a big issue that we wanted to make sure we built these tools so that other people can take what we've built and then implement it in their own in their own systems. So we've published that for free, so anyone can take what we've built and now become a charging station supplier. So when we're talking about dedicated and shared charging stations, normally a charging station will use up to 32 amps on a 240 volt outlet. And a car really doesn't need that much power all the time. On a typical day, an average driver will plug in when they get home, and they'll need to charge for about 2 hours to get fully charged again. So having that much power is great because it reduces the time that it takes to charge the car versus having to plug into a 110 outlet, which might take 8 hours or 14 hours to charge up. But when you move to a MURB and to a multi-unit residential building, you might have 1,000 parking stalls, and eventually all those stalls will need one of these outlets for an electric car. And having 1,000 40 amp breakers, one for each of those outlets, is going to be a huge cost. The transformer feeding the building would need to be replaced. After a building has about 80 residential units, BC Hydro will no longer be able to supply the transformer that they normally would supply with that building. So then the building would have to buy a transformer and build a receiving room for that transformer, which will probably take up 4 or 5 stalls that they didn't plan on having to lose. So there is a solution to all this because the cars don't need 40 amps all the time for each car. You can share that power across all the parking stalls and with other building loads, but that means you have to measure the actual consumption of the charging stations and the other loads, and then you can turn down charging stations through software when they're not needed or when the price of power. So in BC we don't have time of use pricing for power, but in Ontario they do. So they might want to reduce the power during the evening from 5 p.m. till 8 p.m., which is really expensive power, and then allow cars to charge faster starting at 9 or 10 p.m. So shared power solution, as I was describing, so each charging station would be connected to a dedicated 40 amp breaker, and so with this type of solution, charging won't be as fast, but it will still get the job done in a reasonable time for everyone, and as long as it's designed with minimum metrics in place, everyone will have a full charge by the time they need to leave. So at the aerospace campus in Richmond, we did one of these setups where we installed 6 charging stations, and we were using excess power from the streetlights in the parking lot. This was not typical because it's 347 volts using 3 phases, which a car can't use to charge. They can charge at 110, 120 volts, and as well as 208 volt and 240 volt. Anything higher, they can't use directly through the normal level 2 chargers. So we had to put in a transformer, which is shown next to the street light. And then we trenched and installed these 6 charging stations. And so each 2 charging stations that are grouped together have share 6 kilowatts each. And overall, when all of them are in use, we can only supply 14 kilowatts of power. And with cars that are parked at this lot, they're typically there for 8 hours a day, and so they're fully charged by when they're finished their workday. Hey, Clay.
Thanks, Kelly. So yeah, the idea here is to leverage street lighting infrastructure. That was kind of the backbone of this project. Street lighting infrastructure is already installed, and a lot of municipalities across the country are in the process of retrofitting the fixtures from older technology, sodium vapor and metal halide, to much more energy efficient LED lighting. So it depends on the characteristics of the fixtures that you're retrofitting, but usually for every 10 to 20 that you retrofit, you're going to free up enough capacity for an electric vehicle charging station. And using technologies like Kelly's just described with load management, you can get even more than that. So in this installation, we were able to put in 6 chargers, and we also paid for the retrofits of the street lighting there. It's kind of an ideal scenario because the street lighting, the electrical capacity has to be installed to keep the street lights on, but they're typically not on during the day when all of the cars are parked there. The street lighting comes on at night, and especially at the Aerospace Technology Campus and a lot of commercial parking lots, the parking lots are empty at night. Joey talked a little bit about garage orphans. So garage orphans are illustrated quite well in this photograph here. If you don't have access to off-street parking, it's really not all that advisable to buy an electric vehicle charging station. So these people are parking on the street. It's a code violation to run an extension cord over the sidewalk. It's a tripping hazard. You can't trench because you're crossing the boundary between your own property and the city property. There's buried infrastructure here. So there's just no easy way to get the power out there. But with street lighting, again, the infrastructure is already there. So we partnered with the City of New Westminster to do some demonstrations out there. These are some of the sites that we selected. So the red stars are the new locations. So we've got 5 locations, a total of 12 chargers. The one installation that's not quite complete yet is at Queen's Park. The blue stars denote existing charge stations. So we came up with these locations by we engaged with the city, who had a series of engagements with the community to find out where there was need for the charging stations, to try and locate where the garage orphans live in the city. And also we had to do a lot of due diligence looking at the electrical infrastructure in the city. Now, City of New Westminster is a very old city, and the electrical infrastructure for the street lighting in cases is really old. In some cases, they're tapping off the overhead wires, which is not suitable. There's nothing down at street level. And in some cases where they had already done some LED retrofits, they'd done those in communities that were, again, not really good candidates for street lighting. They'd done them in new neighborhoods that had plenty of off-street parking. If a homeowner wanted to put in a charge station, there was nothing preventing them to installing one in their garage. So we did find some locations in the city that had older street lighting that was suitable, and we, again, foot the bill to retrofit to LEDs and put in the either load-managed or share-managed charge stations. We also were on the hook to do some testing on harmonics. So without getting into a really detailed discussion of what harmonics are, when you've got perfect power, you get this nice sinusoidal sine wave of power. But as you add electrical devices, that sine wave starts to degrade. If you buy an electrical device, like a TV or sewing machine, whatever, it comes with a CSA label, either CSA or CUL. They inspect it to make sure that those harmonics don't exceed certain levels, so it's not going to damage other equipment that's on your circuit. The charge stations that we install also have CSA labels. But a charge station, a level 2 charge station, is basically a glorified receptacle. The actual charging circuitry is internal to the car. That's not inspected by CSA. It's not inspected by CUL. The Society of Automotive Engineers puts a label on it, but we don't really know how much testing they've done on harmonics. So what we did was we used our collection of 6 level 2 chargers down at Oasis, and we ran some tests. We put some advanced metrology on those chargers so that we could measure their harmonics, and then we would get collections of cars, all the same kind of cars. So we had all Nissan Leafs, for example, charging simultaneously, and then we measure their harmonics to see exactly how much is on there. The reason we're doing that is, for example, City of Vancouver and City of Richmond have just passed legislation where 100% of the new MURB installations, when they build a new MURB, 100% of the parking has to be provisioned for electric vehicle charging. We really don't know what that's going to look like. We don't have any installations right now where we've got, dozens or hundreds of EV charge stations. So we needed to do some tests here to find out what's going on. The good news is that the vehicles that we've tested so far, harmonics is not an issue, but we're continuing to investigate this. So on the what's next, we are submitting proposals for more funding on the OCPP ecosystem that Kelly described. So fleshing this out, so we've got the Open Charge Point Protocol, and Open Charge Point Protocol is an evolving protocol. Version 2.0 has just been announced. We're also going to be integrating Open ADR. Open ADR is Open Automated Demand Response, and that gives utilities visibility into your charge network, and it gives them the ability to control, to some degree, the level of charging. Roaming is another area that we're going to be tackling, assuming we're successful with funding. That allows you to use any of your charge cards. Right now, you need a different charge card for each different network. But with roaming, that gets simplified, and you can just bring your own card, and you can automatically roam between charging networks. And Kelly's already talked about payment card industry, PCI compliant payment. I think we're at the end. We are. Questions?
Is there a possibility for implementing something like a way for people to denote how long they're going to be sitting at the charging station, so you can prioritize people who are there for a shorter time, or something like that? Would that?
So the question was, is there a way to prioritize people if people are only going to be there for a short time? Right now, no. The short answer is there's not a good way to do that. There is, for example, what's out there right now that a lot of people are using is PlugShare. So with PlugShare, you can indicate their which charge station you're at. You can indicate that you're only going to be there for a short time, so that somebody has got an idea as to whether that thing is going to be available by the time they come around. But that is not implemented in this right here. That's a separate application.
Is there a
Jamie?
role for wireless charging, or what's the state of the art of wireless? Where do you see that?
Wireless is that's something that we want to do with this previous project. And when we started the project, there was product on the market. Since then, there are no products on the market right now. We can't get any. And there's a really good reason for that, and it's standardization. So J2954 is the SAE standard that is being worked on right now. So it's at an early stage right now, and the vendors that have wireless product are all doing testing in the US. There's 3 independent labs that are doing testing. So on interoperability, safety, and so on. So the end result is that that testing is going to take about a year. So in about 9 9 months, you may start to see product on the market again. And the good news is that it will be interoperable. So you may even be able to buy a vehicle that's already got the wireless technology embedded into it, and then it'll work with any vendor's product. So wireless charging has got huge implications for autonomous driving. So you could buy a Tesla, and it could be autonomous driving, but it can't fuel itself. With wireless charging, it can. And that's something, it's a huge differentiator between internal combustion engines that cannot fuel themselves. Any other questions?
Okay, thank you very much to Clay, Kelly, and Joey. I just want to add a couple of things to this. I work quite closely with the SMART group. One, they report up to me, but two, it's also my area of expertise in terms of electrical stuff. So I'm quite familiar with stuff. They're probably too bashful to announce, but they've actually won a number of awards around the projects they're doing, and they're being honored again on Monday by the City of Burnaby for a sustainability award that they have won. They're also named one of the top 50 projects in BC, technology projects in BC last year to keep an eye on, and the team and the director, Dr. Hassan Frangi, were winners of the Employee Excellence Awards last year for the work they do. So it's a great project, well worth checking out more if you haven't, even if you don't have an EV vehicle. So thank you guys for all the great work.